Hey guys, in this video I'm going to run you through all the solutions for the AQA 2024 AS level paper 1. Every section is going to be timestamped so you can easily skip to a question or rewatch one if you need to. Hope this helps. Okay, so going straight for question 1, it says it is given that tan theta equals k, where k is a constant. Can we find the value of tan of theta plus 180? Well, the graph of tan repeats every 180, so it's still going to be at the same value if we just add 180 onto the input. So it's still going to be just k. Then question 2 says the curve C has equation y equals 1 over x minus 1 squared. State the equations of the asymptotes of the curve C. So that's just a graph transformation of 1 over x squared. So if f of x was 1 over x squared, this guy is just f of x minus 1, which is just a graph transformation that shifts everything to the right by 1. So the normal asymptotes of x equals 0, y equals 0. The vertical asymptote of x equals 0 is going to shift to x equals 1. And the horizontal asymptote, well, if you shift that horizontally, it doesn't really do anything. So that's still going to be y equals 0. So it's going to be the third option here. Moving on to question 3, it says express this fraction in the form of a plus root b. So notably, that's it's not a fraction anymore, which means it's definitely got a rational denominator. If you want to think about it, it's a denominator of 1. So we're just rationalizing the denominator. So to do that, we're going to change the sign of one of the terms on the bottom and multiply that through onto the top and bottom. So writing that out, that would be root 3 plus 3 root 5 over root 5 minus root 3. Then I'm going to change the sign of the root 3, so that means we're going to multiply by root 5 plus root 3 on the top and bottom. And I'm allowed to do this because that's just 1. If you think about it, anything divided by itself is 1, and we can always multiply by 1 without changing the fraction. So following through with our multiplication, we'll have root 3 times root 5, that's root 15. Then we'll have root 3 times root 3, that's plus 3. Then we'll have 3 root 5 times root 5. That would be 3 times 5, which is 15. And then we'll have 3 root 5 times root 3. That's a plus 3 lots of root 15. And then in the denominator, we'll have root 5 times root 5, which will be 5. We'll have a root 5 times a positive root 3. That would be a plus root 15. A minus root 3 times a positive root 5. That would be a minus root 15. And then a minus root 3 times a positive root 3. That would be a minus 3. And we can see that's worked nicely and it's cancelled out these cross terms here. So we just have a rational denominator. So if we simplify now, in the numerator, we'd have, grouping this the regular terms, the 3 and the 15, that would be 18. And then grouping the irrationals, the surds, you'd have plus 4 lots of root 15. And then in the denominator, we just have 2. And then there's a factor of 2 on everything, so we can actually divide through by the 2, which would give us 9 plus 2 root 15. And then we're not quite in the final form because we need to have it as a plus root b, and I've got this 2 here. So to do that, we can think of 2 as the square root of 4. So that'd be 9 plus root 4 times root 15, which is the same as 9 plus root 60. Okay, moving on to question 4. It says, by using a suitable trigonometric identity, show that the equation sine theta tan theta equals 4 cos theta is the same as tan squared theta equals 4. Well, we want to get rid of the sine theta and cos theta and ideally generate a new tan theta, so it would be smart to divide by cos theta because sine theta over cos theta is tan theta. So if we do that, we'd have sine theta over cos theta times the tan theta still equals 4, which is just a tan theta times a tan theta. So we have tan squared theta equals 4. Then for part 2, it says hence solve the equation. So that's the same equation that we started with. So rather than solving that, we can start with just tan squared theta equals 4. And then we got a square root here to get tan theta. So that means tan theta could equal 2, and tan theta could also equal minus 2. Because if we square both 2 and minus 2, we still get the 4. And then to get our solutions now, we're going to need our calculator. So they want it in degrees. So I'll quickly make sure my calculator's in degrees. And then to get our first solution, we're going to use the inverse tan function. So that'd be shift tan, and then inverse tan of 2 gives us 63 degrees, or 63.4 degrees. Well, to the nearest degree, it's going to be 63 degrees, actually. So theta equals 63. And then we actually want all the solutions between 0 and 360. So the tan graph repeats every 180 degrees. So I can add 180 to this and get another solution, which would give me 243 degrees to the nearest degree. Now let's do the same process, but for the tan theta equals minus 2 equation. So inverse tan of minus 2. That first gives us minus 63.4, which is not in our range, but we can do the same trick. We can add 180. That gives us our first solution of 116.56, which actually would round to 117 to the nearest degree. And then we can actually add 180 one more time. So I'm just going to hit execute one more time. And that's going to be 296.56, which would round to 297 degrees. And then I can't add 180 any more times without going beyond 360. Okay, so now it says deduce all the solutions of the equation sine 3 alpha tan 3 alpha equals 4 cos 3 alpha. And notice they say deduce, so that means we're not calculating. So our previous work's going to be important. And actually it's the same equation, except the theta has now become a 3 alpha. So if we take all our theta solutions, so theta, which is actually equal to 3 alpha, which is 63 degrees, 243 degrees, 117, and 297 degrees. And then we can just divide by 3 to get the new solutions for alpha. So 63 divided by 3, that gives us 21 degrees. 243 divided by 3, that gives us 81 degrees. 117 divided by 3, that gives us 39 degrees. And 297 divided by 3, that's going to give us 99 degrees. And then we'll actually notice, well, we're quite far away from 180, so we can probably get some more solutions as well. Well, if we go back and think about the same trick that we did before, where we could add 180 degrees to these solutions, because of the tan theta graph repeating every 180 degrees. Well, what we're solving here is like tan of 3 alpha equals plus or minus 2. And this 3 alpha just squashes the graph by a factor of 3, or stretches it by a factor of a third. So if before we could add 180 degrees, now actually we can continue to add 60 degrees and get new solutions. So if you notice, these guys are actually already separated by 60, as well as these two guys here. So we can add in some more solutions just by adding some 60 degrees to these. So 81 plus 60, that's 141 degrees. And we can't add 6 anymore because we go past 180, but we can add it to 99. So 99 plus 60, that's 159 degrees. And that would be all the solutions we can fit in that interval. Okay, so going for question 5, it says a student is looking for factors of the polynomial f of x. They suggest that x minus 2 is a factor of f of x. The method they use to check this suggestion is to calculate f of minus 2, and they correctly calculate that f of minus 2 equals 0. They conclude that their suggestion is correct. So he's trying to use factor theorem, so it's a quick way of checking his assertion that he's used the wrong value. If x minus 2 was going to be a factor, then x equaling 2 would actually give you the solution or set the factor to 0. So a comment is he should have checked f of 2, not f of minus 2. And make 2 comments about the student's conclusion. Well, actually, we don't know if he's wrong necessarily, because we could still check f of 2 and it come out correct. So, undetermined, we'd say. Whether x minus 2 is a factor, as still need to check that f of 2 equals 0. And then the other comment is, well, he has actually found another factor. So the fact that the fact that f of minus 2 equals 0 does imply that x plus 2 is a factor of f of x. Okay, so moving on to question 6, it says determine the set of values of x which satisfy the inequality 3x squared plus 3x is greater than x plus 6. So in this inequality, we only have linear and quadratic terms and a constant. That makes it a quadratic inequality. So we can bring it all to one side first. That would give us 3x squared plus 2x minus 6 is greater than 0. And then I don't think that factorizes very nicely, so I'm going to use my calculator here, as I think the marks aren't coming from solving this quadratic, it's from solving the inequality. So let's take the easy option to find our roots to make this easy. So go to polynomial solver, check the quadratic, let's type in our coefficients. So it's 3, 2, and minus 6. And yeah, so the roots are horrible, so that was a good decision. Whenever I solve an inequality, I'll plot a graph if I don't already have one. So this guy is going to have roots at -1 plus root 19. So let's say that's over here. And then, sorry, let's write that down as well. -1 plus root 19 over 3. And then the second one is -1 minus root 19 over 3. That's over here. And then it's a positive quadratic, so it's going to come down like this. It should have gone through that root, sorry. Okay. And then we're interested in the sections where it's greater than 0. So that's these two tails here. So that's all the x values to the right of here and to the left of here. So let's write those two sets out, and then we'll worry about combining them. So as two individual sets, that's a set of x values where x is strictly less than -1 minus root 19 over 3. Running out of space, let's just move that. And then the other set is going to be a set of x values, set of x values where x is strictly greater than -1 plus root 19 over 3. And then we want a set that contains all those, so it can be in one set or the other and still be a solution. So that would be a union of the two sets. Moving on now to question 7, it says a triangular field of grass ABC has boundaries with lengths as follows. AB equals 234. We've got the other lengths written out there. Can we find angle A? So angle A is the angle located at the vertex A. And we have all three sides of this triangle, meaning we can use the cosine rule. So writing out the cosine rule, that would be this: a squared equals b squared plus c squared minus 2bc cosine of A. If we rearrange for cos of A, then that's going to be b squared plus c squared minus a squared all over 2bc. And then we'll just do inverse cos of that. So if we do that in our calculator, that would be, so shift cos, oops, need to get out of here. So shift cos, and then fraction, so b squared. Let's just label these sides. So this is side A, and this is side B and C. So B and C, we've got 2, 3, 4 squared plus 310 squared minus 225 squared all over 2 times BC, so 234 times 310. So that gives us angle A to be 41 degrees. Or actually, let's do it to three significant figures. So 46, if I read it correctly, 46.3 degrees to three significant figures. Then going for part B, the farmer calculates the number of sheep they can keep in a field by allowing one sheep for every 1,200 meters squared of grass. Find the maximum number of sheep which can be kept in the field ABC. So we're going to need to find the area of his field. Well, now that we have this angle A, we can actually use the sine rule, like half AB sine C. As we have the angle between two known sides. So we have this angle between these two guys here. I've labeled the sides differently. This is just how I remember the sine rule. But it's going to be AB is going to be the angles either side of the angle we know, the sides either side of the angle we know, and the C it's now is the 46.3. So writing that out, that's going to be A equals a half times our opposite side, so times 234 times 310 times sine, right, sine of C should have been there, sine of our angle, which is 46.3. So let's type that out now. So that angle's still on my calculator, so we'll use that. 0.5 times 234 times 310 sine of my answer that was stored before for the angle. That gives us 26222.5 ... meters squared. And then to see how many sheep, we just need to divide that up into sections of 1,200. So if we call n the number of sheep, it's our 26222 0.5 ... over the 1,200. So let's divide that through now. 1,200. That gives us 21.85. But we can't have 0.85 of a sheep, so it's going to be 21 sheep maximum. Moving on to question 8. It says, it is given that the natural log of x minus the natural log of y equals 3. Express x in terms of y in a form not involving logarithms. Well, if we want to get rid of the logarithms, we need to condense it down to one log. So first off, if we use the rule for subtraction of logarithms, that means division inside the logarithm. Then we'd have the natural log of x over y equals 3. Then if we use just the basic property of a log, so go back to the exponential form, that would be x over y equals e, as the natural log is log base e, so e cubed. And then if we want to express x in terms of y, we just move up the y, so x equals e cubed times y, and that's part A done. Then for part B, it says, given also that x plus y equals 10, find the value of y and x. Well, now we have two equations involving x and y, so we can solve them simultaneously. So as we've already got this one rearranged, I think I'm just going to substitute into the second one. So we could write e cubed times y plus y equals 10. And then if we factorize out the y, we can rearrange. So y, open bracket, e cubed plus 1 equals 10. So y equals 10 over e cubed plus 1. Then if we want to go back and get x, x is just going to be 10 minus y, which means it's just 10 minus 10 over e cubed plus 1. And they haven't asked for it in any particular form other than it's exact. So we don't want a decimal, we want a precise thing, and both of those are exact. So those forms are fine. Moving on to question 9. It says a curve has equation y equals f of x, where that is x times 6 minus x. And it says, can we find f dash of x? We need to differentiate. So let's use our power rule to do that. We're going to need to expand the bracket. So that would give us f of x would equal 6x minus x squared. And differentiating then, we'd have f dash of x would just be 6 minus 2x. So that's part A done. Then part B says the diagram below shows the graph of f of x. On the same diagram, sketch the gradient function for this curve, stating the coordinates of any points where the gradient function cuts the axes. Well, it's going to cut the axes once in each, so if we look at this, it's just a straight line. It's going to cut the y-axis at 6, and it's going to cut the x-axis. If we think about setting this to 0, that would be when x equals 3. That would be here, which notably is directly in line with the maximum point, because that's where the gradient of our quadratic is 0. That makes good sense. And then we can just draw in our straight line between those 2 points. Oh, it's not going to like that very much. Let's just use the normal tool. There we go. Moving on to question 10. It says, it is given that dy by dx is x plus 2 times 2x minus 1 all squared. And we know a point on the original curve would have been x equals 6 when y equals 900. So can we find y in terms of x? So if we want to go back to an expression for y in terms of x, we need to reverse the differentiation, i.e. integrate. So to integrate, we're going to have to expand again. So let's start by just expanding the double bracket of the 2x minus 1 squared. That would leave us with x plus 2 times 4x squared minus 4x plus 1. Now let's expand that. So dy by dx would be, well, let's think, we're going to get 1x cubed term just from the x times the 4x squared. So that would be 4x cubed. Then we're going to get 2x squared terms. We'll get 1 from the 2 times the 4x squared and 1 from the x times the minus 4x squared. So that would give us 8x squared and then minus a 4x squared, so just a plus a 4x squared. Then for the x term, we'll get 2 again, because we'll have 2 times minus 4x. That would be minus 8x. And then we'd have a plus 1 times the x. So that'd be minus 8 plus 1, that's minus 7x. And then we'd have a plus 2 times plus 1 would be the only constant term on the end, such as plus 2. Now we have our powers of x we can integrate. So that would give us y equals, raising the power by 1 divided by the new power, just be x to the 4. Then we'd have 4/3 of x cubed, then minus 7 over 2 x squared, plus a 2x, and then plus c. To find our plus c, we need to use our point. So we know that 900 equals, well, let's just plug the number in, 6 to the 4 plus 4/3, 6 cubed, minus 7 over 2, 6 squared, plus 2 times 6, plus c. So to find the plus c, I need to move all those constants to the other side. So let's use our calculator for that. That'd be 900 minus 6 to the 4 minus 4/3 times 6 cubed and the next one will be plus 7 over 2 times 6 squared. Then we're going to have, well, 2 times 6 is just 12, so just take away a 12. Which gives us a plus c of minus 570. So it would be y equals x to the 4 plus 4/3 x cubed minus 7 over 2 x squared plus 2x minus 570. Moving on now to question 11, it says it is given that for a continuous function g, g dash of 1 equals 0, g dash of 4 equals 0, and g double dash of x is 2x minus 5. It says determine the nature of each of the turning points of g. Well, first off, the turning points would be at x equals 1 and x equals 4, because the turning points occur when the derivative is 0. And then we can evaluate whether they're maximums or minimums easily normally by just plugging into the second derivative. So that's why they've given us that. So if we plug in x equals 1 into the second derivative, so that's g double dash of 1, then that would give us 2 lots of 1 minus 5, which is going to be minus 3. That's negative, so that implies it's negative, that would imply a maximum at x equals 1. Oops. X equals 1. And then if we do the same process now for the 4, g double dash of 4, that's 2 lots of 4 minus 5, which gives us positive 3, which is greater than 0, and that implies there is a minimum at x equals 4. Then it says, can we find the values of x for which g is an increasing function? Well, we could probably go about this a couple ways, but I think what I'm going to do actually is let's find our first derivative by integrating the second derivative, because increasing means that our first derivative, is greater than 0. So that's where g dash of x is greater than 0. So to get g dash of x, that's just the integral of the second derivative, so that's 2x minus 5, which is going to be x squared minus 5x plus c. And to get the plus c, well, we know the first derivative is 0 when I type in 1 or 4. So we can say then that 0 equals 1 squared minus 5 times 1 plus c. So c then would be equal to 4. Yeah, 4. So we're interested in, we haven't got any more space there. We're interested in where x squared minus 5x plus 4 is greater than 0. So that's a quadratic, and we actually know the roots already. We know the roots are at 1 and 4. So if I draw a very small sketch here, oops, it's going to look like this, where that's 1 and 4. I'm interested in where the graph is greater than 0, so that's where x is less than 1 and where x is greater than 4. Moving on to question 12, it says the monthly mean temperature of a city, T degrees Celsius, may be modeled by the equation T equals 15 plus 8 sine 30m minus 120, and it's measured in degrees, notably. Sorry, the trig function understands degrees. I mean, it's measured in degrees Celsius. And m is the month number, counting January as 1 and then so on. So it says, using this model, calculate the mean temperature of the city for May, which is the 5th month. So it's just when you sub in m equals 5, right? So that would be T equals 15 plus 8 sine of 30 times 5 minus 120. Plugging that in our calculator, that's 15 plus 8 sine 30 times 5 minus 120, which is 21.1 degrees. It hasn't asked for a specific rounding, so I'll use three significant figures, so 21.1 degrees. Using this model, find the month with the highest mean temperature. Okay, so we're interested in making this function a maximum. So that would be when our sine bit is 1, right? Sine on its own can go between 1 and minus 1. And if we want it to be as large as possible, then we'd want it to be 1. So that would give us a T max, would just be 15 plus 8 times 1, i.e. it would be 23. So if we just think about where that came from, we could set T to 23, or we could just realize that came from when we said sine of 30m minus 12 minus 120, excuse me, needs to equal 1. So if we do inverse sine of that happens on the regular sine graph. Oops, sorry. 30m minus 120. Sine of that equals 1 when on the regular sine graph for 90 degrees. And we could also plus or minus 360 if we need to get more solutions. I don't think we're going to need to here, though. So if we then solve that for m, that would be 90 plus 120, and then divide that by 30, that gives us the 7th month, which is July. Uh, 12c then says climate change may affect the parameters 8, 30, 120, and 15 used in this model. State with a reason which parameter would be increased because of an overall rise in temperatures. So what we have to think about is what those parameters do to this function, or the graph, really is the easiest way to think about it. So if we think about it, overall it's a sine graph. And then these guys, well, the minus 120 is a translation of the sine graph. So that's just going to change like where the maximums and minimums occur at what values of time. Which maybe that could be explained like different months having different peak temperatures in different parts of the globe, but not really explaining global warming. 30 is a stretch, so that's probably to do with the fact that we've got a 12-month cycle. That's why we needed a stretch. But again, I don't think that's an obvious connection to global warming. Then 8 is a stretch vertically, so that means it oscillates up and down by 8 degrees from this 15. So I think that is probably a reasonable thing to talk about. You probably get bigger fluctuations in temperature as well. But I think the most obvious thing is just the average temperature. So we're averaging 15 degrees and we're going 8 above and below. Whereas if global warming's happening, that average temperature is going to continue to rise. I think that's the most obvious answer is that the 15 would be greater as the average temperature is increasing. Then for part 2, it says state with a reason which parameter would be increased because of the occurrence of more extreme temperatures. Okay, so again, I mean that would affect the extremeness of it as well, but I think they're probably more referencing this guy because that's the determining like how far up and below 15 we go. So it's going to be extreme in both directions. So the 8 would be larger. So the fluctuations of the function from 15 would be greater. Okay, just making a quick correction. So somehow I managed to type something in here wrong. Sorry, guys. This is the correct line of working, but I must have just typed in the calculator wrong. So this is what I've typed in again now, which is the same line of working you can see. And if you execute that, it gives you 19 degrees exactly. So that answer should have been 19 degrees. So sorry about that. Moving on to question 13, it says a particle is moving in a straight line with constant acceleration a meters per second squared. The particle's velocity v meters per second varies with time t seconds, so that v equals 3 minus 4t. So it says deduce the value of a. Well, we can get the full acceleration of a by just differentiating, which would leave us with a minus 4. So the answer for that is just minus 4. Moving on to question 14, it says we have two forces written as vectors are added together to find a resultant force. The vector addition can be represented using a diagram. Identify which diagram is correct. Well, if we're adding two vectors, we add them tip to tail. And it doesn't matter actually if we did f1 plus f2 or f2 plus f1. But we can see these guys, like this is not added correctly. These have got like both their tails added. Well, this one is tip to tail, but it should start from f1 going out this way and then ending up here. So that arrow is wrong. And then actually this guy is right in the bottom left. We go from f1 to f2 and then we go along that way following the arrows. And then you can see 4 is wrong again because it's added up wrong. Moving on to question 15, we've got a VT graph. It says find the total distance, importantly distance traveled by the particle over 8 seconds. So that's just going to be the total area under the graph, which I think I'll do as 2 trapeziums. So we've got this first trapezium here. So that's half the sum of the, like for each trapezium, it's half the sum of the parallel sides times the distance between them. So for our distance for trapezium 1, it's going to be a half of the parallel sides of this guy and this guy. So the bottom side is 5 and the top side is 2. That's half of 5 plus 2 times the distance between them, which is just 3 for that distance there. Then our second trapezium, we've got another trapezium, so half of this and this. So that's another, that's 3 and then 1 for those parallel sides. and then the distance between those two is also 3. We'll ignore the minus as we're just dealing with the distance traveled. Then if we just simplify that, so that's a half times 7 times 3 plus a half times 4 times 3. And I'm just going to use a calculator on that. So 0.5 times 7 times 3 plus 0.5 times 4 times 3. That gives us 33/2 meters. Then for part B, it says, a student claims the displacement of the particle is less than the distance traveled. State the range of values of t for which that claim is true. So the distance traveled and the displacement are different because displacement is how far away you are from your original position. So during this whole section, the velocity is positive, so that the particle is traveling one way up to t = 5. And then after that point, it starts to travel backward. So it comes back some amount, the area of this trapezium. So let's read the question again. State the range of values of t for which the claim is true. So the displacement of the particle is less than the distance traveled. So up to t = 5, the displacement is the same as the distance traveled because he's only gone to the right. He hasn't turned around at all. So after t = 5, his displacement actually starts to become smaller and the distance traveled grows. So it's going to be everything above t = 5. Or maybe if we want to just include the journey for, of 8 seconds, it would be t is greater than 5 but less than 8. Moving on to question 16. It says a ball is launched vertically upward from Earth's surface with velocity u. Let's have a little sketch of this, I think. So velocity u, and if it's on Earth and there's no forces acting on it other than gravity, it's going to be accelerating down at 9.81. Or 9.8, sorry, in this exam. The ball reaches a maximum height. Let's say that's there. So this is 15 meters. You may assume that air resistance can be ignored. Cool. Okay, so what do we know? We've got information about from the start point to the maximum height. So we'll do that. We'll use that, and it's going to be a SUVAT as the acceleration's constant. So if I think about using SUVAT where I take up to be positive, then our displacement is 15. U is the U. We don't know V, but we know A is minus 9.8. And we also know if we're at the maximum height, then our final velocity is 0. So we'll use that actually, sorry. Cool, so then if we want an equation without t to be able to find u, that's s equals ut plus a half at squared. Sorry, without t, what am I talking about? That would be v squared equals u squared plus 2as. So that would be 0 equals u squared minus 2 times the 9.8. I'm just preempting that minus sign with that there, times 15. So u is going to be the square root of all that. And putting that in a calculator. Oops, 9.8 times 15. That gives us that as a decimal. That's 17.1 meters per second. The 3 significant figures. Moving on to question 17. It says a particle moves in a straight line with acceleration a at time c seconds. So note that the acceleration depends on time, so it's not constant, meaning we're going to need to use calculus if we want to find other things. We can't use SUVAT. The particle's velocity v and displacement r meters are both initially 0. Cool. So we know that v of 0 equals 0 and r of 0 equals 0. And then it says show that the position function is given by that there. So first we have to go from acceleration up to position. We're going to have to first get to velocity by integrating once. So v of t is the integral of 10 minus 6t dt, which is going to be 10t minus 6t, sorry, not 6t, 3t squared, plus a constant, subbing in t equals 0, and so they're using this thing, v is 0 when t is 0, then we'd get c would equal, oh sorry, let's just write it out. 0 equals 10 times 0 minus 3 lots of 0 squared plus c. So that means c is just 0. So then to get r of t, we can just integrate again. So that's the integral of 10t minus 3t squared dt. That's going to be 5t squared minus t cubed plus another constant. I'll call that c prime. Then if we use this property here, we know that 0 must equal 5 lots of 0 squared plus 0 cubed plus c prime. So c prime must also be 0, meaning that we can actually just say that this bit is our function overall, and we can factorize out the t squared. Just realized I've written a minus sign wrong, sorry. So that's a minus there. That doesn't affect our calculation at all. Minus, minus. Yeah, so if we factorize out our t squared, we'd have r of t would be t squared 5 minus t like they asked for. Okay, moving on to question 18. It says it is given that 2 points A and B have position vectors as shown there. Show that the distance from A to B is 10 meters. Well, first off, we can get the vector that goes from A to B by just doing O to B minus O to A. Then, so that would be 13, 5 minus 5 minus 1, which is going to be 8, 6. And then the to get the distance, it's just the magnitude of that vector. So the magnitude of AB is the square root of 8 squared plus 6 squared. Typing that in our calculator gives us 10. Sorry, yeah, show that it's 10. So that's that confirmed. Cool. Then part B says a constant resultant force of magnitude r newtons acts on a particle so that it moves in a straight line passing through the same 2 points A and B. Well, if we think about F equals ma, if F is constant, that means A is constant, which means we can use SUVAT equations. So if we start thinking about SUVAT now for our journey from A to B for the rest of this, then at A, the speed of the particle is 3, so that's our initial speed is 3. We actually know the distance from before, don't we? It was 10. So our displacement's 10 meters. V, sorry, no, we don't know V. We know the particle takes 2 seconds to get to the end, and it wants us to find r, so that resultant force. So we're going to need the acceleration. We're not going to need the final velocity. So we want an equation without v. That would be s equals ut plus a half at squared. Rearranging for a, we're going to get s minus ut all over a half of t squared. So plugging that in our calculator, that's going to be 10 minus 3 times 2 all over a half of 2 squared. That gives us 2 meters per second squared. Then using F equals ma to find r, that's going to be r equals the mass as 150 grams. We need to convert that into kilograms, so that's 0.15 kilograms times our acceleration of 2, which is just going to be 0.3 newtons. Moving on to question 19, it says two objects M and N are connected by a light inextensible string. So we remember that those words are important. That means that the acceleration are the same for both particles if it's inextensible, and light means the tension in the string is the same for both. Over a smooth peg, so we don't need to worry about any friction. M and N have mass of 0.6 and 0.5 kilograms respectively, so let's put that in. That'd be 0.6 g and 0.5 g. And then the tension is going to act on these guys, so it's going to be up on both of them. And it's the same tension again for that same reason I said before, the fact that it's light. It is given that M and N move an acceleration a by forming two equations of motion show that a equals 1 over 11g. So we should already be thinking F equals ma because it's a familiar problem, but they've just told us that the equation of motion, the only one we know is F equals ma anyway. So if we do F equals ma, and we've got to be careful with our directions. So we know m is going to move down or accelerate down, and n is going to accelerate up. So I will take those directions to be positive in each of my equations. So for mass m going down, we'll get 0.6 g minus t equals 0.6 a. And then doing the same thing, but for mass n, and now we have to consider that one going up, that's going to be t minus 0.5 g equals 0.5 a. And we're after the acceleration, so we'd like to eliminate t. We can do that just by adding the equations, because the minus t and t would cancel. So that would give us 1.1 g equals 0. Use the masses correctly, sorry. Oh, sorry, no, it's not going to be that. It's 0.6 minus 0.5, isn't it? Not because if we're adding, it's going to become a minus. So yeah, it will be 0.1 g on the left equals 1.1 a on the right. I'm sorry, just to fully clarify, it's because if we add these two equations, this guy is going to be added, so it'll be 0.6 plus minus 0.5 g. Then that's going to, if we just rearrange it now for a, we'd have 0.1 g over 1.1, which is the same if we multiply the top and bottom by 10. Just to simplify it, that's the same as just 1 over 11 times g. Then for part B, it says the speed of n 0.5 seconds after its release is g over k, where k is a constant. So the accelerations are constant again, so we can use SUVAT again. So, oops, where's my iPad? That's clever. So yeah, we can do SUVAT on n. So n is traveling up, so we'll think about SUVAT going up. So we don't know the displacement. We do know it starts from rest, I believe. Yeah, so that if they're released, they're going to start from rest. So yeah, u is 0. V is what we're actually after. Yeah, we want the speed after the 0.5 seconds. So we want v. A is what we worked out. It's the 1 over 11g. And t is half a second. So we want an equation without s. That's just v equals u plus at. That's going to be v equals 0 plus 1 over 11g times 0.5. That would make it 1 over 22g. Which you can think of as g over 22. So that's that means k is just 22. State one assumption that must be made for the answer in part B to be valid. So they've told us it's initially at rest. Let's release. So we'd have to assume that both the string would be under tension the whole time, so that none of the masses are going to hit anything. That would be reasonable. Yeah. Yeah. Oh yeah, because so maybe just from looking at the scale of this diagram, there might be a chance that n could hit this. So we'd say the paths of the particles need to be unimpeded for that half a second. So paths of particles are unimpeded. For that 0.5 seconds. That's the end of the video, guys. I hope you found it helpful. If you did, please drop it a like, that helps me out a lot, and consider subscribing to the channel to find out when I release new videos. Thanks, and I'll see you in the next one.